You are standing on a beach. The water stretches out in front of you until it meets the sky. It looks vast. It looks endless. But what you can see is not the ocean. What you can see is the roof of it. The real ocean is what lies underneath. And of that ocean, the part that actually matters, the deep, the dark, the immense volume where almost all of Earth's living space exists, humans have explored less than 5% of it. Read that again. 95% of the ocean is still a mystery. We have better maps of the surface of Mars than we do of our own seafloor. We have sent 12 people to walk on the moon. We have sent 3 to the deepest point of the ocean. In the entire history of our species, more humans have flown to space than have descended to the bottom of the sea. And the reason for this is not what most people assume. Most people assume we have not explored the deep ocean because we have not tried. That assumption is wrong. The truth is stranger and more physical, and in some ways more humbling. Here is where it gets interesting. The ocean is not one environment. It is a stack of environments, each one behaving like a different planet. At the surface, sunlight, warmth, and wind. 10 meters down, colors begin to disappear. Red first, then orange, then yellow. By 50 meters, everything looks blue-gray. By 200 meters, sunlight is gone. This is the beginning of a zone marine biologists call the twilight zone. Below it lies the midnight zone. Below that, the abyssal zone. And below even that, the Hadal zone, named after Hades, the Greek underworld. At each level, the rules change. Pressure is the first problem. At the surface, you are under 1 atmosphere of pressure, 14 pounds per square inch. It feels like nothing because you are built for it. Every 10 meters you descend, another atmosphere is added. At 1,000 meters, the pressure on your body would be equivalent to a small car pressing down on every square inch of your skin. At the average depth of the ocean, around 4,000 meters, that number climbs to nearly 6,000 pounds per square inch. Your lungs would be crushed. Your bones would splinter. The gases dissolved in your blood would collapse. Now go to the bottom of the Mariana Trench, 11,000 meters down. The pressure there is over 16,000 pounds per square inch. That is the equivalent of 100 elephants standing on a postage stamp. And yet things live there. Marine biologist Jameson Allen of Newcastle University has been dropping baited landers into the deepest ocean trenches for over a decade. In 2023, working in the Izu Ogasawara Trench near Japan, his team recorded a snailfish at 8,336 meters, the deepest fish ever observed alive. It was small. It was translucent, and its body was built entirely differently from anything at the surface. Its cells were flexible. Its bones were partially unmineralized. It contained a molecule called trimethylamine oxide, or TMAO, which literally holds proteins together against the crushing weight of the water. Without that one molecule, life at that depth would be impossible. Here is where it gets stranger. We have technology that can survive those pressures. Deep submersibles like the DSV limiting factor, piloted by explorer Victor Vescovo, have reached the bottom of every major ocean trench. The problem is not whether we can go. The problem is what happens when we do. Light does not travel underwater, not the way it travels through air. Water absorbs and scatters photons, which is why the ocean gets dark so quickly. This means that even with the most powerful lights ever built, a submersible can only see a few meters in front of it. In terms of exploring a landscape, this is the equivalent of trying to map an entire continent using only a flashlight, and only being allowed to shine that flashlight from directly overhead. Sonar helps. Sound travels far better than light and water. Modern multi-beam sonar can produce detailed maps of the seafloor. This is how we have mapped what we have mapped. But sonar has limits too. The resolution drops with depth. A ship traveling at a normal speed can only map a strip of ocean roughly the width of a highway. To cover every square kilometer of seafloor at the level of detail we have already used for Mars, it would take thousands of ships, thousands of years. Most of the seafloor has been mapped at a resolution where a single pixel represents an area roughly the size of a football stadium, which means, effectively, an entire mountain range down there could exist, and we would not know it. And this is not a theoretical concern. In 2020, oceanographer Robin Beeman of James Cook University and his team discovered a coral reef in the northern Great Barrier Reef that was 500 meters tall, taller than the Empire State Building. Right off the coast of Australia, a place we thought we knew. It had been there for millions of years. We had not seen it. But that is not the strange part. The strange part is what the ocean does to time. Down in the deep, life moves at a completely different pace. In 2016, biologist Julius Nielsen of the University of Copenhagen dated a Greenland shark and estimated its age at nearly 400 years old. That single shark was born before the American Revolution. It had been swimming through the North Atlantic while empires rose and fell. And it was still alive. Down in the cold, dark, oxygen-poor water, biological time slows almost to a stop. Some deep-sea corals have been aging for over 4,000 years. Some deep-sea sponges may live even longer. If you want to see something that has watched most of human civilization happen, do not look at a mountain. Look at the deep sea. Here is the deeper question. Why is the deep ocean still so unknown? The answer is not one thing. It is many things. It is the pressure. It is the dark. It is the size. It is the fact that the ocean holds 300 times more habitable volume than every other environment on Earth combined. When you count every forest, every desert, every mountain, every atmosphere layer where life exists, and you compare that to the volume of water where life can survive, the ocean wins by a factor of hundreds. Most of what has ever lived on this planet has lived down there. Most of what is alive right now lives down there. And most of what is down there we have never seen. Marine ecologist Sylvia Earle has said that we have explored more of space than of the ocean. She has been saying it for decades, and each year the numbers back her up. NASA has an annual budget of over $20 billion. The National Oceanic and Atmospheric Administration's exploration budget is a small fraction of that. The moon is 384,000 kilometers away. The deepest point in the ocean is 11 kilometers straight down. The one is politically inspiring. The other is dark and cold and does not photograph well. But that quiet, ignored place is where we came from. Every animal alive today, including you, evolved from ancestors that lived in the sea. The oxygen you breathe was, over hundreds of millions of years, largely produced by microorganisms floating in the ocean. The rain that falls on you began as ocean water. The nitrogen cycles that feed the crops you eat are shaped by ocean processes. You do not just live near the ocean. You live because of it. And here is what the science is only now beginning to reveal. The deep ocean is not empty. It is thick with life. In 2011, oceanographers on the Census of Marine Life project estimated that there may be between 1 and 10 million species of animals in the ocean, most of them still undescribed. Every single deep-sea expedition, without exception, brings back new species, not one or two, sometimes dozens. Fish that produce their own light, worms that live inside boiling hydrothermal vents, bacteria that survive by eating rocks. There are ecosystems down there that do not depend on the sun at all. In 1977, geologist Robert Ballard and his team on the submersible Alvin discovered hydrothermal vents on the Galapagos Rift. Around these vents, at depths where sunlight had never reached, they found tube worms taller than a person, giant clams, blind shrimp, an entire ecosystem powered by chemistry instead of light. Bacteria at the base of the food chain were pulling energy from hydrogen sulfide, a chemical that is poisonous to most surface life. This changed biology. It opened the possibility that life could exist on other worlds where sunlight is absent. Europa, Enceladus, the icy moons where oceans hide beneath frozen surfaces. The deep ocean is not just Earth's biggest secret, it is a preview of alien life. And it is right here. Now think back to that beach, the water in front of you. What you see is a thin skin over something enormous. Under that skin, in the vast darkness that begins just a few hundred meters below the surface, are mountains higher than Everest. Trenches deeper than any canyon, ecosystems that predate every civilization, creatures older than nations, chemistry we do not fully understand, species we have not named, and in some places, complete darkness that has never once been interrupted by sunlight since the moment the ocean formed. For most of history, humans looked at the sky and imagined we could reach it. And we did. We built rockets. We walked on the moon. We sent probes to the edge of the solar system. It was beautiful. It was ambitious. It was human. But while we were looking up, the largest and oldest environment on our own planet was quietly waiting beneath us, not asking to be explored, not needing to be understood, just being what it has always been, vast, dark, alive, and almost entirely unknown.